Hello and welcome. In this video we want to do a limit question involving radical. Find numbers a and b such that the limit of radical ax plus b minus 3 over x when x approaches 0 be equal to 5. When we have a limit question, for finding the limit, usually the first step that we do for finding the limit is direct substitution. For a moment, forget that we have the value of this limit. We know that we have to find numbers a and b such that this limit be equal to 5. But for a moment, forget this. If you have this limit and you want to find this limit, basically the first thing you try for finding this limit is direct substitution. So let's see what happens if we plug in 0 in numerator and denominator. If we plug in 0 for x in denominator, denominator is 0. And because from this question we know that this limit is equal to 5, so basically this means that this limit should exist. And because when we substitute 0, the denominator is 0. So if we substitute 0 for x in numerator, the numerator should also be equal to 0. Because otherwise, if the numerator is non-zero, a non-zero over something that approaches 0 would be infinity, and so the limit does not exist. So, because substituting 0 for x makes the denominator 0, if we substitute 0 in numerator, the numerator should also be 0. If we plug in 0 for x in numerator, we get radical b. Attention, if we plug in 0 for x, a times 0 is 0. So only b remains in the radical. So we have radical b minus 3, and this should be equal to 0. By solving this simple equation, we can find the value of b. If we raise both sides of this equation to the power of 2, b equals 9. Now only we have to find the value of a. So basically, let me rewrite the limit with the value that we found for b. b was 9, so radical x plus 9 minus 3 all over x as x approaches 0. Now we have to find a such that this limit be equal to 5. For finding this limit, we multiply numerator and denominator by the conjugate of their radical. This is what we do for finding limits involving square root. If we multiply numerator by the conjugate and the denominator by the conjugate, we can get rid of the radical in numerator. By doing this, we get ax plus 9 minus 9 in numerator. When we multiply this by its conjugate, the radical cancels and the 3 raises to the power of 2, so basically then we have 9. If you want to learn more about finding limits by this method, by multiplying by the conjugate, watch my video about finding limits by this technique. I'm not going to tell all the details here in this video. And in the denominator, we have x times radical ax plus 9 plus 3. If we simplify numerator, 9 and negative 9 cancel each other and only ax remains. if we cancel x from numerator with the denominator, then we have a over radical ax plus 9 plus 3. Attention, this x cancels with this x, and this is 0. Now if we plug in 0 for x, in denominator this is 0, a times 0 is 0, 0 plus 9 is 9, radical 9 is 3, plus 3 is 6. So we have a over 6. But if you remember, we want to find a and b. Already we have b. We want to find a such that this limit be equal to 5. So we have to find a such that a over 6 be equal to 5. And so from this, a equals 6 times 5, so a equals 30. I hope you liked this video, and see you in the next videos.